Today we're going to talk about dividing radical expressions. Before we can move into dividing, I want to review radical multiplication. First step to radical multiplication is if you multiply the numbers on the outside of the radical and place them on the outside of the radical. So if you have numbers like 2 radical 3 times 4 radical 3, you're going to multiply the 2 and the 4 and keep them on the outside of the radical. Second step is to multiply the numbers on the inside of the radical and place on the inside of the radical. So using the same example, if you have 2 radical 3 times 4 radical 3, you're going to multiply 3 times 3 and keep that under the radical. If you have a binomial, you're going to need to use FOIL, the distributive property, to multiply, and then once all the multiplication is done, you can simplify the radical. A term that I use when we're dividing radical expression you'll hear is conjugate. Conjugates are expressions that differ only in the signs of the second term. For example, the square root of a plus the square root of b and the square root of a minus the square root of b are conjugates of each other because the sign is different here. The first sign is being plus square root of b, and this is minus square root of b. Another term you'll hear me say is rationalized denominator. That's a denominator that does not have a radical. The first example we're going to look at is 12 divided by radical 3, or square root of 3. Okay, the goal is to rewrite the expression with a rational denominator, and a rational denominator is something that contains no radicals. So I need to get rid of the square root of 3 here. Now to do that, I'm going to take 12 divided by the square root of 3 and multiply it by the square root of 3 divided by the square root of 3. Now we know in math that this quantity here is going to be 1. Anytime you take a number divided by itself, it's 1. So I'm not changing the problem, I'm just manipulating using this little technique. So remember, when we multiply fractions, we multiply across the top and the bottom. So if I continue on, I'm going to have 12 times the square root of 3. And then on the bottom, I'm going to multiply square root of 3 times square root of 3. And then this simplifies to 12 times the square root of 3 divided by the square root of 9, which simplifies to 12 times the square root of 3 divided by 3. And I can simplify this one more step because 12 divided by 3 is 4. And that's my final answer. And the second example I'm going to do is 7 divided by the square root of 11. So again, I want to rewrite the expression with a rational denominator, which means no radicals in the denominator. So to do that, I multiply by the square root of 11 divided by the square root of 11, and then we just multiply fractions. We multiply across the top. So I have 7 times the square root of 11 divided by the square root of 11 times 11, which gives me 7 times the square root of 11 divided by the square root of 121, which when I simplify it is 7 square root of 11 divided by 11. Now, it's tempting to want to mark out the 11 here and 11 here, but they're not the same. The square root of 11 is not the same as 11, so I'm done with this and I cannot simplify it any further. Okay, our third example, we're going to start doing binomial with radicals. And again, the goal here is just to rewrite the expression with a rational denominator, which means no radicals. So the example I'm going to do here is 2 divided by 3 minus the square root of 7. So my steps to doing binomials with radicals is a little bit more involved. The first step I want to do is identify the conjugate of the denominator. Now remember our definition, the conjugate is the expression where the sign of the second term is different. You have the same first and second term, the sign just changes. So the conjugate of 3 minus square root of 7 would be 3 plus square root of 7. My next step would be to multiply the numerator and the denominator by the conjugate using FOIL, the distributive property. So it would look like this. Again, I'm not changing the problem. This again is equal to 1. I'm just manipulating the problem to get rid of the radical in the denominator. And then step 3 would just be to simplify. But once we get through here, so 2 times 3 gives me 6, and then 2 times 7 gives me 2 radical 7. So then if I multiply the bottom, 3 times 3 gives me 9. Then 3 times square root of 7 is positive 3 square root of 7. Negative square root of 7 times 3 is negative 3 square root of 7. And then negative 7 times positive square root of 7 is negative square root of 7 times 7. Okay, when I go to simplify, I notice that these terms are going to cross out. That is why we multiply by the conjugate. We want to get rid of the radical sign. So then this simplifies to 6 plus 2 square root of 7 divided by 9 minus the square root of 49, which we know is 7. So that would be simplified to 6 plus 2 square root of 7 divided by 2, which I can simplify one more time down to 3 plus square root of 7. And that's my answer. Can't simplify anymore. So let's look at another example. Okay, this one is a little bit trickier, where I have radical on the top and the bottom. Again, my steps stay the same. First thing I need to do is identify the conjugate of the denominator. Again, the conjugate is the sign of the second term is different. So this would be 1 minus the square root of 3. Second step is to multiply the numerator and the denominator by the conjugate using FOIL or distributive property. So we're going to take and multiply this out. So if I do that, and then we'll simplify. So to multiply this, I take 3 times 1, and that's where I get the 3. 3 times negative square root of 3, place that here. 6, square root of 6 times 1 is there. And then square root of 6 times the square root of 3 gives me the square root of 18. Remember, when you multiply, you put the numbers under the radical, keep the ones on the outside. Then I'm going to multiply in the denominator. 1 times 1 gives me 1. 1 times negative square root of 3 is negative square root of 3. Square root of 3 times 1 is positive square root of 3. And then the square root of 3 times negative square root of 3 gives me the square root of negative square root of 9. Okay, again, I know that when the goal here is to get rid of the terms, so when I see that, when I simplify, I see that they cancel each other out. And on the top, I'm left with 3 minus 3 radical 3 plus radical 6 minus square root of 9 times square root of 2 divided by 1 minus the square root of 9. That simplifies to 3, which is 2. The top cannot be simplified any further because there are no like terms, and it's my final answer. Okay. Make sure you complete the form that is shown under the link to this video on my website. Make sure you bring your notes and questions with you to class tomorrow. And if you're still having trouble with simplifying radicals, please come see me or let me know, and I can get you some help in study hall if you have one. Thanks, and I'll see you tomorrow.